In lesson 1.3, we are going to review the process for solving literal equations, or equations that have more than one variable. In these situations, we're going to use skills and practices very similar to those that we used in lesson 1.2. In lesson 1.2, we solved for the one lone variable in an equation. In these equations, in section 1.3, we're instead going to choose one of the available variables and try to solve for that. Fortunately for us, the process is very similar. We will use the order of operations in reverse, inverting all of the steps along the way to isolate the desired variable. This first equation is the equation for finding the area of a sector of a circle. In this situation, we are looking to solve for capital S, which is a representation for the area taken up here, specifically the measurement of that angle. That angle allows us to figure out the area of the sector of the circle. But there might be a situation where instead of having that angle and needing to find the area, we might have the area and want to find that angle. In that situation, it would be beneficial to have an equation that was solved for S. We identify the variable S in our equation right here. We look around that variable S and we see a multiplication, another multiplication, and the division from the denominator of 360. All of the work we will do in this example will live in this line of the inverted order of operations. We will undo the multiplications with division, and we will undo the division with multiplication. We start by multiplying by 360. The grouping symbol that is the fraction bar means that 360 would normally come last. So in this case, we'll get rid of it first. That produces a 360a and leaves us with pi r squared s in the numerator. Instead of dealing with the pi and the r squared all in two different steps, because they're both multiplications, we can handle them in one step, and we get rid of pi r squared all in one move. These two will simplify to 1, and we're left with s is equal to 360a over pi r squared. We solve for s by using the inverted order of operations. In this next example, we're going to do something similar. Here we have the formula for the area of a trapezoid. In this specific situation, the easier of the two situations, we are trying to solve for the letter h. But if you look carefully around the letter h, you see this multiplication here and that multiplication there. And that's it. Resist the temptation to distribute the 1/2 h. I know that's what we're used to do when when we solve, but here that would just create two h's. If we're trying to solve for the only h, we need to leave that only h by itself. That being said, we're going to get rid of the two multiplications with division. If we divided by 1/2, that would be kind of a wonky way of getting rid of that 1/2. It actually makes more sense for us to get rid of that 1/2 by multiplying both sides of the equation by 2. We move to the next line with 2a, and we have h times b1 plus b2. Again, I don't want to distribute. I don't want to create two h's when I only have one h that I want to solve for. So in this situation, because there is a multiplication right here, I am allowed to divide by the entire quantity that is being multiplied by h. I can divide by all of b1 plus b2 simultaneously. That eliminates that as a factor and leaves behind h equals 2a from the numerator and b1 plus b2 as the denominator. Once again, inverting the order of operations and reversing all of the steps. Same exact formula, but this time we're going to try to solve for one of the variables on the inside of the parentheses. It doesn't matter which one you choose. The formula for the area of a trapezoid has a plus sign inside the parentheses, so it doesn't matter if you're trying to solve for b1 or b2, the process would be the same. In this situation, we've chosen b1 just for the sake of simplicity. We see this addition here, and then we see the multiplications on the outside of the grouping symbol. If we follow the order of operations, you would normally say, well, let's get rid of the multiplication and then the addition, but we really want to drive home the fact that we want that B2 to go away last. That B2's presence is inside of that grouping symbol. He would be the first thing that would normally be done. Because he is the first thing that would normally be done, he must be the last to go. You must handle those terms that are on the outside and then work your way to the inside. So in this situation, we're going to do something similar as to the last one. We're going to handle that 1/2 by multiplying by 2. We're going to move the 2 to the other side. And then we're going to get rid of the h. So instead of getting rid of the b1 plus b2, we're going to move the h over. And that gives us 2a over h is equal to b1 plus b2. And again, because that b1 plus b2 was in the parentheses, it needs to be dissolved last. And we do that by subtracting b2 from both sides, ending with a final answer of b1 is equal to 2a over h minus b2. And that's our final answer. We're okay with the fact that this first part of this answer has a fraction and this second part is a lone term. If you really wanted to put the two of them together, it would look like this. You would need to give b2 the common denominator in order to put them together and have them subtract into one big fraction, but that's not necessarily something we need to do. If we follow the inverse order of operations, this would be the answer that we would get. And in our last example, we're going to do something very similar to the last one. We're going to identify in here this as the variable that we are trying to solve for. We are trying to solve for the x. You might recognize this formula as the point slope formula of a line. If we're looking to solve for that x that's on the inside, not x1, but the first x, we're going to see a minus or a subtraction after it inside of a grouping symbol. Similar to the last question, that's going to have to go last. And we'll need to eliminate this m first. That's a straight multiplication, similar to the h in the last formula. So we'll get rid of that with a division. So we have y minus y1 over m equals x minus x1. And very much like the last example, we're going to add away the x1. It will not be part of the numerator. It will not be part of a fraction. It will be its own term, separate as part of the sum. You could engage in a similar behavior as the last example, where you tried to create a common denominator to combine them together, but it's unnecessary. If the objective was to solve for the variable x, we have accomplished that objective. Early on this year, we're not so concerned, or early on in this course, we're not so concerned with what these answers are going to look like. We're going to need to be able to be fluid with the manipulation of them as we move through this course, but it's not necessary right now for us to produce every single different version of the answers. But again, we follow the same process. We invert the order of operations and we reverse all of the steps.